Good evening friends, you are most welcome to Think Eyes channel. Today we are going to discuss Practicing Anthropology, which is written by MAAN IGNOU, and our topic is Physiological Anthropology and Kin Anthropometry. Let us begin the topic. Kin Anthropometry and Anthropometry. Since athletic performance for a particular sport depend greatly on proportionality, the role of anthropometry is vital as it is where we can attain an account of the physical dimensions of athlete through it and then evaluate the relative meaning of these body dimensions by comparing two aspects using, for example, the mean of anthropometric variable for the athletes and comparing this to other reference populations. These investigations assist us to enumerate the value of characteristic body structures and to recommend functional advantage for athletes in particular sports. The bright side of such results would show more the mean of the sport resemble the mean of the population, more are the chances of potential pool of athletes from which to select. The commonly used measures for anthropometric profile for athletes giving high performance are stature, sitting height to the stature ratio, upper limb length to the stature ratio, brachial index, that is ratio of length of the forearm to length of upper arm, and level of body fatness assessed using the sum of skin fold, waist to hip ratio, waist to height ratio, and body mass. Let us understand each of these. Stature plays an important role in the success of any sport event. An excellent example showing the magnitude of the interaction of height and other physiological performance can be best understood in the running events. Have you ever noticed that as one moves from the shorter distance races to marathon, that is at both the extremes in terms of the height of the athletes, most of them are short. What could be the reason for it? The shorter distance have a comparatively longer acceleration segment and consequently slightly low mean speed, which support shorter athlete with relatively short legs, whereas in longer distance excess muscle mass is hindrance, necessitating substantial energy to be exhausted for its transportation and yet has relatively low power production. This demands the athletes to be typically small, lean, and have low body mass index. Short stature is predominantly favorable in acceleration and changing direction. It permits decrease in moments of inertia which owing to conservation of angular momentum throughout angular motion make easy increased angular velocity. Thus a smaller athlete can spin faster achieving more turn than tall athletes and are beneficial for events such as gymnastics, skating, ballet and diving. Nevertheless, some pressure is maneuvered towards selection of big athletes as they are competent, requiring a relatively lower energy cost per distance traveled. It is known that maximum force produced by body is proportional to cross-sectional area of each muscle, and since muscle and bone of smaller athletes are stronger in proportion to body weight, it gives them more agility and are less likely to get injured from high velocities activities and hard landing resulting from sports such as rock climbing, sky jumping, etc. It is not that tall stature does not have any importance in sports. Sports such as volleyball, basketball, rowing, etc. are favorable to tall stature athletes. Tall players' requirement is to take jump lower relatively to percentage of their statures. This facilitates them to reach above net height for the ball. Sitting height to stature ratio gives a suggestion of the relative length of the legs to stature. The extremes in the ratio are found for athletes in sports requiring upper body segments such as wrestling at weightlifters, sports such as volleyball, basketball, etc., which has the component of jumping need relatively short trunks. Successful rowers have proportionally longer limbs and shorter sitting height, which provide a mechanical advantage during competition by allowing lower stroke length. Additionally, shorter sitting height lessens front surface area, a source of resistance to movement. Upper limb to stature ratio is negatively correlated with sitting height to stature ratio. This means that individuals who have relatively long trunks will have relatively short arms. Longer arms are beneficial as they mechanically present longer stroke lengths, useful in swimming and rowing. In throwing events, it also gives the athlete a longer lever to accelerate an object. Long arms exploit the release velocity of the object, giving the largest distance for amount of muscle mass. Athletes such as shot putters, javelin, or disc throwers who need a single and large push also benefit by this sort of relationship. As per the understanding of many researchers, greater shoulder width and arm length could be an advantage in throwing tasks. In case of swimming strokes, it is the shoulder joint that provides the majority of the propulsive force. Brachial index is represented as length of forearm relative to upper arm. A high brachial index in general is beneficial for sports in which longer propulsive drive of the forearm is desirable. A high brachial index facilitates for longer stroke length since the forearm is a longer lever, resulting in increasing the velocity of the hand at the end of the stroke. It contributes as an important factor in throwing sports as javelin and disc or the discus throw, where the athlete want to have the thrown object at the highest possible velocity the moment it leaves the hand. On the other hand, a lower than average brachial index presents better strength and stability, whereas an athlete who has a low brachial index tends to have shorter forearms, which benefit in athletics such as shot put, in which an immensely strong push is needed. This arises since the muscle mass is more concentrated in the arm. Body mass and body fatness too play a vital role in certain sport events. Take the case of rowing. It is purely the forward motion of the shell or boat which is the absolute power that the other person generates. In the throwing events, body mass is one of the factors responsible for performance along with the acceleration of the implements prior to its release, but the work capacity decreases with the increase in the body fat as the increased body fat acts as dead weight. In sports which essentially require speed or explosive power, example, sprinting or jumping, excess fat will increase the body mass and decrease acceleration in view of the fact that heat generated in the course of increased metabolism of the working muscle ought to be lost via evaporation, convection and radiation. The body surface area to body mass ratio is of great meaning in the efficiency of the dissipation heat dissipation. As observed in leaner counterparts, the heat loss is more effective when the ratio is higher. The amount of heat energy necessary to raise the temperature of a given mass of adipose tissue is lower than that of fat free mass due to the fact that there is difference in water content. A given heat load consequently increases the temperature more in overfed than their leaner counterparts. Nonetheless, in swimmer or in swimming body, the body fat provides greater buoyancy to swimmers and adds to enhance efficiency by decreasing hydrodynamic drag. Let us repeat this. Nonetheless, in swimming, body fat provides greater buoyancy to swimmers and adds to enhance efficiency by decreasing hydrodynamic drag. This is due to the fact that fat layer acts as thermal insulator to conserve body heat in the water. In spite of high rate of heat production during competition, not considering the type of sport discipline, on an average athletes are less fat and more muscular than non-athletes. It is realized that body weight does not convey the total picture regarding the fitness of a sports person. In most of the sports, there is lesser requirement of extra fat, providing greater mass of muscle and bones. It has been observed that those athletes have been found to be superior in performance in sports like football, shot put and weightlifting. Athletes who possesses considerable amount of adipose tissue have increased energy demands due to inert weight of fat, consequently rendering the work more difficult to carry out in endurance activities where the body has to move longer with greater weight. This could perhaps be reason for long distance runners to be less fatter than other runners in lower level competition. It thus becomes evident that body fat plays an important role in a sports person's which needs to be determined. Lean tissue and subcutaneous tissue have vital function to play in physical performance. These two components are known to influence physical performance and vice versa, which means that the participation of an individual in demanding physical activity increases or decreases the amount of lean and subcutaneous tissue. Generally, it is observed that in players subcutaneous tissue is less and lean tissue is more. Also, due to the nature of activity in the field, it is observed that the two components may differ even among the players of the same game. Let us take hockey as an example. Among hockey players, lean tissue plays significant role in forward halves because more muscular upper extremity facilitates the players to hit the ball with forces, and similarly more muscular calf allows the player to run fast, and it is also recognized that a lot of running around is required. The less amount of subcutaneous tissue also aids the player while running as the player will have to carry less weight.